Hello. In this lecture, we'll discuss the type of operator that are basically used in C programming, and then we'll discuss different examples with respect to this operator. Then we'll discuss the input output, and finally we'll discuss the type conversion. So, what are the different types of operators that are basically available in C programming? Initially, we'll discuss the arithmetic operator. So, it is basically the arithmetic operator. So it basically used to perform the mathematical calculations. For example, addition, subtraction, multiplication, then division and modulus operations. Relational operators, then logical operator and bitwise operator. So relational operator are basically used to compare the values. For example, equal to, not equal to, greater than, then less than equal to, greater than equal to, etc. And logical operator basically combine or negate Boolean expression. Example are and, logical and. This is basically the representation of symbol, logical or and not operations. Now, bitwise operator. Bitwise operator are basically, symbol is basically the single ampersand sign, and it basically represents the bitwise AND operator, or XOR, left shift, then right shift, okay, and it is a complement. So these are basically the bitwise operators. Next, increment decrement operator. Increment and decrement operator. Plus plus and decrement is minus minus. So this is basically the increment operator, and this is basically the decrement operator. Both of these operators are basically the unary operator. Unary operator. Okay. And then there is another operator known as a conditional operator or condition operator. Condition operator. Condition operator symbol is colon. Clear? First we have to do a question mark, then followed by colon. This is basically symbol. Sometimes this condition operator is also called the ternary operator. Ternary operator. Okay. So the condition operator, and then there is a comma operator. Another operator is known as the comma operator. Comma operator. Okay, symbol is this, just comma operator. And another operator is also there, that is sometimes we call it as a size of operator. So size of operator, it basically returns, or it basically gives size of the data type in terms of byte, size of operator. Yeah. So these are basically the various kind of operator. Now we'll give example of this operator. So look here, this is an example of the logical operator. Yeah. So what will be the output of this following code? So first, the output of this following code will be, initially what is the value of x is equal to 1, y is equal to 0, and z is equal to 5, right? Now a equal to x and y. So here x and y means the value of x is equal to 1, then logical and operator y equal to 0, and then followed by or then z plus plus. So now in this case, logical and means if any one of the value is 0, that means the expression gives you the output 0. And then or operations, z plus plus. So initially the value of z will be here, because this increment operator is basically called the post increment. So increment operator, if we apply plus plus, suppose a, then it is a pre increment, and if we write it is a plus plus, it is a post increment. So difference is, in case of plus plus a, pre increment means first increment the value, then use it. So it means increment the value, increment the value, then use. And this is a post increment. It is basically use the value, then increment. Right? Now, so it basically first use the value, so it is a 5. Clear? So now 0 or 5. So any non-zero value, it is basically false, and any non-zero value means it is considered as a true. Okay. Now in case of OR operation, true or false always gives you the output true. So the value true means basically non-zero, and here it is a true, false means 0, or it is true. So that's why value 1 will be stored in A. So the value of A will be 1. Now what will be the value of Z? So once it uses the value 5, then it increments the value. So now the value of 5 will be incremented to 6. Right? So now the output of this program, percentage D and Z, is basically, percentage D is basically control string, and printf is basically the keyword or reserve word. To print integer, we have to use the percentage D. Now Z, the value of Z will be printed, and the output of this program or the code is 6. And if we print value of A, it will be the 1. So this is logical operator, one of the example of the logical operator. Now we'll give example of the bitwise operator. And bitwise operator, now what is the output of this bitwise operator? Look here. Here C equal to 2. This operator is basically known as the XOR. Clear? It is basically XOR operator. So now it will perform bitwise operations. Okay. So 2 in binary representation. Suppose we represent, for simplicity, we assume that we represent every number in 4-bit. Okay. So 2 will be represented using 4-bit, and 3 will be represented using 4-bit. So 0, 0, 1, 0 is the binary representation of 2, and 3 binary representation with 0, 0, 1, 1. Now if we perform this XOR operation, clear with this, so in case of XOR operation, this will give the output 1. Okay, and when the same bits are same, at that time it will give 0. So it is 0, 0, and 0. So this is basically the equivalent value of decimal number. It will be the value of 1. So now the value 1 will be stored in C. So the C basically stored 1. So now if we print the value, the output will be 1. Now we'll give the left shift operation, or left shift operator. So this symbol is basically the left shift operator. Now on the right hand side, 1 means one cell left shift operation should be performed. Okay. Now here the value of x is equal to 2. So let's see the value, we can assume that integer, suppose the integer is a 2 byte. Okay, 2 byte, and 2 is basically a signed number, right? Positive, but we consider it is a by default int x, it is a signed number. Signed means it has both representation, positive as well as negative, but here 2 is given, so that is, it is a positive 2. So total number of bits will be 16. Okay, and the first or left most significant bit, it is basically the sign bit. Okay, sign bit, and remaining portion is basically the magnitude. Is basically the magnitude. Okay, now 2, as it is a positive, so 0 is basically used for the positive, and 1 is basically used for to represent the negative in the sign bit. So sign bit will be this sign bit. If 0, so for positive, sign bit will be 0. For negative, sign bit will be 1. So as it is a 2, so sign bit is positive, so it is a 0, and 2 will be represented its corresponding binary value. So magnitude will be 0, 0, and so on. Clear? And this, and this. So it will be 2 means 1, 0 is basically binary representation of 2. So now this 15 bits, 0, 0, 0, 0, 0, and last 1, 0. So this is basically the 15 bits. So from here it is a 15 bits, and 1 bit is reserved for the sign. This 1 bit is reserved for the sign. So total from here to here, we assume that it is a 16 bit representation. Okay, now if we shift towards the right, sorry, towards the left, one cell will be shifted towards the left. So this 0 will comes to here, and this one will comes to here. Clear? And what happened here? So this is sign bit, and 0, 0, and this it will be 1, then 0, and the rightmost bit will be filled up with the 0. So now what is the representation of this number? It is basically the number 4, because binary represent 4, and it is a 0 means positive 4. So the value, now the value of x will be this, and it will be print in decimal number. So the output will be 4. So the answer is basically the 4. It is basically 0, 4. This 0, 4, its corresponding binary representation is 1, 0, 0. Now what will be the output of the following code? It is a -2, right? So here it is a -2. So -2 means, if we represent, so negative number is represented in computer in 2's complement form. Clear? Sign 2's complement form. So as minus, so we know the sign bit will be 1, and remaining bits. So remaining bits, what will be the remaining bits? What will be the remaining bits? Here we know that rest is basically magnitude. So the magnitude will be represented using the 2's complement form. Clear? 2's complement form. So now what is the value of 2? So here we write it. It will be like this: 0, 1, 0. It is the positive binary represent magnitude. It is basically the magnitude of the positive 2. Only the magnitude part, not the sign part. Magnitude. Yeah, clear? Now we have to make it 2's complement. 2's complement means we have to complement 0 to 1 and 1 to 0. So it will be 1, 1, and it will be 1, 0, 1. Now we have to add 1 here. Okay. Now we add 1. So the result will be, if we add 1, result will be 1, 0, then 1, and all are basically 1, 1. Okay. So this is basically, so 1, 1, and here also 1. So this, and it will be 1, 1, 0. So this is basically the -2 representation. Clear? So x basically contains this value -2. Now if we shift right one cell, so what will happen? So this will filled up with this, and this will filled up with this, and so on in that way. Okay. So then what will happen? So in that scenario, the value of x will be, all are basically 1. If we make a shift operation, the value of this value will be, all are basically 1, and this 1 and 1. Clear? So the value of x now, it will be 1 after shifting operation. Right shift one cell. Okay. Now what will happen? This is basically the representation of -1. So it is basically the representation of -1 in computer, because negative number is represented in 2's complement sign, 2's complement form. So the output here will be -1. Now why it is -1? Because uh, look into this. Here 1 is basically the sign bit. So obviously, as it is a 1, so here we write this. Suppose this is the number, okay, 1 and 1 and 1, etc., etc., given here 1 and 1. Now this is a sign bit, okay, it is a sign bit. So it basically represents the negative, and remaining is basically the magnitude. So if we want to know what is the actual magnitude value of this, we have to again make this magnitude in 2's complement form. So if we make 2's complement form, so what is the rule? 1 will be converted to 0 and 0 will be converted to 1. So all 1 will be converted to 0. So 0, 0, and so 0, 0. Now we have to add 1. Clear? Then it will be 2's complement. So if we add 1, so 0, 0, and this is 0, 1. So this is basically the magnitude. So its corresponding decimal equivalent value is 1, right? This is basically 15 bit, okay? And so again, and the sign bit is minus. So the output is basically the -1, okay? Now we'll discuss bitwise NOT operations. So here, look, complement of 0, right? It means complement of 0. And complement of 0 is always -1. It is always -1. Why? Because 0, so if we represent 0, so it will be 0, and remaining part are also 0, 0, 0, and 0 if we represent 16 bit. Now if we make complement, so it basically complement means 0 will be converted to 1 and it will be 1. Okay, if we make complement of this, now here, okay, now what is the value of this? This is sign bit, so it is minus, and this is basically the magnitude. So if we want to know that in decimal equivalent value of this, as it is a negative, so we have to make this magnitude part into again 2's complement. So as you have seen in the last example, that all 1, then it will be equivalent to basically the -1. So it is basically the -1. Okay. So now if complement 0 means it basically gives you the -1, and it's compared with a 1. Obviously this condition is not satisfied, because -1 is not equivalent to 1, not equal to 1. So it will go to the else part, right, and print no. So the output will be no. We know that this is a true block and this is a false block. And true block means only if the condition is true, then the true block will be executed, and if the condition is false, then false block will be executed. So the output is basically the false. Okay. Now we'll give another example here. Left shift, as we have mentioned here. Again, this is x, and we have to make 3 times shift towards the left. So as it is a positive, z is equal to x is equal to +1. Okay, so we have to make this 3 shift towards the left. So it is 0 sign bit. Okay, this is basically the we consider that it is a sign bit, and remaining part is the magnitude, and it is a 0, then 0, etc., and it is 1. So it is basically magnitude 15 bits. We assume that it is a sign bit. Now if we make shift towards the left 3 times, so what will happen? So these are basically 0, 0. One shift, the result will be this: 0, 0, 0, 0, 1, 0. It is one shift, right? And second shift, 0, 0, 0, 1, 0, 0. It is a second 2 times shift, 2 cell shifts. Now third shift, this, and it will be 1, 0, 0, 0. It will be third number of shift. Okay, and here basically we think like that. Okay, so what is the value of this? It is a magnitude, right? It is basically the magnitude part. Okay, sorry, it is a sign bit. Sorry, sign bit, and it is a magnitude part. So what is the magnitude value? It is a positive, so we can say positive, and it is a magnitude value means it is basically the decimal value 8 whose corresponding binary representation is this. So the output will be 8 here. Okay, so we have discussed this that operator. Now we will discuss uh, other some operators are also there. Okay, so it is basically the increment and it is a decrement operator. Plus plus, as we have also mentioned that these both the operator are basically unary operator. Unary operator means only a one operand is basically required. uh, that's why we call it as a unary operator. So plus plus, if you write a plus plus or if you write plus plus a, both are basically equivalent to a is equal to a plus 1, but it is a pre-increment as we have mentioned, and it is a post increment. Similarly, if we write a minus minus, it is a decrement. Obviously, it's a post decrement, and if we write minus minus a, it is a pre decrement. Okay, but both are meaning is a is equal to a minus 1. Okay, now this is the condition or sometimes ternary operator. So ternary operator actually we can write in that way. Suppose L equal to I greater than J. I and J are both of the variables, and there is a question mark I colon J and then followed by semicolon. So how it basically evaluated? This is basically known as the test expression. Okay, test expression. Now this test expression may be true, may not be true. So if the condition or of the test expression is true, then this is true and this is basically the false. So now if this condition is true, then I will be assigned to L. But if this condition is false, then J will be assigned to L. Okay? So this is basically the ternary operator. Now comma operator. This comma operator is basically evaluated from left to right. Okay, within an expression. For example, suppose I equal to, if we write J equal to 3 comma then J plus 2. So this is comma operator. So initially the value of J is basically the 3. Now 3 plus 2 is equal to 5. That 5 will be assigned to I. So the here the value of I will be basically the I equal to basically the value of 5. Clear? So now we have discussed different operators. Now we will give some more examples related to increment as well as some other operator also there. You know, first I will give an example of this. Suppose I have these expressions or this code. Suppose void main or int main also can be right. Int x is equal to 5 and there is an a. Okay, now the expression is this: x plus plus then plus x plus plus then plus x plus plus. Now if we print, so printf percentage of d a, then what will be the output? What will be the output of this code? Look, this is all this here, also here. These are basically the post increment. And in case of post increment, it means first it use the value then increment. So in the first case, x plus plus, first it use the value. So the value that basically used will be, it is 5 and then it increments the value. So now the value is incremented to 6. So basically here, after this, the value of x will be incremented to 6. Now when it goes to this expression, then first use the value. Now the present value of x is 6, and then it will increment it. So it is 7. Okay. When it goes to here, it use the present value of x, then 7, then it increments the value. Clear? So finally the value of x is 8. Finally the value of x is basically the 8. Okay. But what is the value of a? So it will be 7, 5 plus 6 plus 7. So 5 plus 6 plus 7. So it is basically 18. Okay. So the output of a will be 8. Now we'll give another example. Suppose int a equal to 3, and b is given, and b equal to a plus plus then plus 5. So what will be the output? What will be the output of b? What is the value that b will be assigned? A, first it is also the post increment. So 3, first it use the value 3, then it increments, it is 4. So the value of b will be 8. 5 plus 3, that is 8. So the value of b will be 8. But what is the value of a? The value of a will be 4. Another example. Suppose int a equal to 2 and b equal to 3 given, and c equal to a plus plus then plus b. Clear? Now what is the value of a, what is the value of b, and what is the value of c? So a equal to 2, as it is a post increment, so first use the value, then increment. Okay. As it is a pre-increment, first it increments the value 4. So first it increments the value 4 and it use the value 4. So now the value of a will be, it is a 3. Value of b will be 4, and value of c will be 4 plus 2, that is 6. Clear? Now for logical operator there is on concept. What is the concept? So, if left hand operand yields false value, the right hand operand is not evaluated in a logical AND operation. For example, int x a equal to 5 and x is equal to, suppose we have written 5 is less than 3, and logical and a plus plus, then what will be the value? If we print a percentage of the a, what will be the value of this a? Look, this is the condition that is a false, 5 less than 3. So as it yields the false value, so right hand operand, basically this is one of the operand and this is left hand side. So this left hand operand yields the false value, as it is a false. So the right hand is not evaluated. Clear? So the value of A will remain same. So the output will be 5 as it is not evaluated. But in case of OR operation, if the in case of OR for logical OR, here what happen? If the left hand operand yields the true value, the right operand is not evaluated. For example, suppose all are same, int x and a equal to suppose 5, and x is written 5 plus 3 or a plus plus. Clear? Now left hand 5 plus 3 is equal to 8, and any non-zero value is basically considered as a true. So it is true. As it is true, so right hand operand is basically not evaluated. Here also if we print, so printf, if we write percentage of d and if we print a, the output will be remain same, a equal to basically the value of a will be 5. The value of a will be 5. Okay. Now another example, suppose, okay, we will give another example. Suppose we have an expression like this, int a equal to 2 and c equal to, suppose also there is a c, and c is equal to a plus 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 a. Then what will be the output? So here it is a post increment, right? So first use the value 2 and then it increments. Now what is the present value of a? 3. First increments the value. It will be 4. Increment this value and then use it. 4. So now what is the value of a now? So the value, if we print the value of a and c, the value of a will be 4 and value of c will be 6. Clear? Now we will give another concept, which is basically the input and output. As we know, in C programming, this printf as well as scanf basically handles this input output operation. Printf and scanf are basically the if you want to print something on the screen, that then printf will be used, and scanf for receiving some values and stored in a memory, that is basically known as the scanf. So generally its syntax are printf, okay, printf, then within double quotation it is a control string double quotation close and list of variables and then semicolon. Okay, now these control strings are basically, this control string means percentage of c for character, percentage of d for integer, percentage of f for float, and so on. Also for double we can write percentage of lf, and for long int it will be percentage of lld, for long int percentage of ld. So these are all basically the control string we have to mention here, and then list of variables. In case of scanf, here also the same control string, then ampersand variable 1, then ampersand suppose variable 2, and so on. So there is a two variable 1 and suppose variable 2. So obviously this control string are basically this. It basically contains the format of the data that we are going to receive. If integer, then we have to write percentage d. If it is a character, then we have to write the percentage of c. If it is a float, then you have to write percentage of f. But what does it means? This ampersand, this ampersand is an operator, and it basically specifies the variable name address. So it basically specifies the variable name address. Okay, for example, if we write scanf, if we write suppose percentage d, and if we write ampersand suppose n, this syntax, this percentage of d basically uh, gives information that we are receiving a integer number, and ampersand n means there is a variable of name n, and this every variable there is an address, and the value that we have received should be stored on that address. So this basically ampersand n means address of the variable n, where we have to put this value. Clear? If we give suppose 5, then 5 will be stored on that address. So this is basically the input as well as the output. Now we discuss the type conversion. Type conversion means it is basically two types. One is the implicit, another is the explicit conversion. As we know, C language is basically a mixing of variables and constant of different types. Integer, float, and mixing, a double, etc. So C language basically converts an intermediate value to the proper type, so that expression can be evaluated without losing any significance. And this automatic conversion is known as implicit conversion. Clear? So in a short, we can write in that way, C language automatically converts any intermediate values to the proper type. Okay, so that the expression can be evaluated without losing significance. Without losing the significance. And this automatic conversion is known as automatic conversion is known as implicit conversion. Clear? These are basically known as implicit conversion. Now, another conversion is basically explicit conversion. Clear? Now, what is explicit conversion? Explicit conversion. This explicit conversion means when to force a type conversion. When to force a type conversion. Clear? For example, we'll give an example. suppose, okay. Now we'll give an example. Suppose we have a code like this, void main, okay, and float, suppose a, and int x equal to 6, y is equal to suppose, and a equal to x by y. And if we print f, suppose percentage of a, why percentage? Because it's a float number, and then a. Then what will be the output of this code? Obviously, here the output will be 1.00 and so on. 1 will be there because x is integer, y is also integer. If we divide, so higher type is integer, so it will only put the integer, and this will be stored when 1, then 1.00 will be printed. So we have lost 0.5 here because actual output will be 1.5. So to obtain this actual output, what we need to do, we have to change this line. If we change this line to a equal to float, then x, y, then at that time it will give you the output 1.500 and so on. Now, what is the meaning of this? This statement, that is float of x, it causes the variable, it causes the variable x to be converted from type integer, because x initially x was integer, so from type integer to type float before used in the division operation. Okay, so before performing this division operation, x first converted to float. So now x is a float, so higher type will be, x is a float and y is integer, so higher type is float. So after division, there is a float, the floating value will be 1.5, that will be stored in a, and the final result will be 1.5 will be printed, and it is the actual result. So this is known as the explicit conversion. So it is an example when we want to perform explicit conversion, we forcefully convert it. So when to force a type conversion, it is basically known as the explicit conversion or explicit type conversion. Okay, thank you.